guys! It's me, Celynne.
And it's me, Diana.
And we're here to give you an idea about permutations. So let's start off with its meaning.
So, permutation is an arrangement in a definite order of a number of objects taken some or all at a time.
If you know how to count well, the topic of permutations will be very easy to deal with. Okay, so for our first example, we have the arrangement of the letters of the word joy.
And so we have to take this word joy and then think of how many ways we can arrange it. So the first option is the word joy itself. Next option will be JYO. And then OYJ. And OJY. YJO. And YOJ. So there are a total of 6 ways on how many times we can arrange the word joy.
If it's a 3 or a 4-letter word, it will be very easy for us to arrange it in this way. But what if it's a 10 or even a 20-letter word? It will be very difficult for us, right?
Right.
That's why we have the power of the formula of permutations.
And note that whenever we deal with permutations, order is very important. The 3 theorems of permutations.
So, Theorem 1 is where all objects are different, then the required permutation formula is NPR equals n factorial over quantity n minus r factorial, where r is greater than or equal to 0, but r is also less than n. So it will become 0 is less than r, but r is also less than n. So, for you to understand the first theorem, we will be giving you guys an example.
Using 4 spaces, find out how many times we can create a word using the letters of the word crystal. So we can see that the total number of letters in the word crystal is 7, which is basically n equals to 7. Now, if you look at the problem, they're asking us to use 4 spaces at a time to create a word. So we can create the given spaces needed to write a word, which is basically r equals to 4. So in order for us to find out how many words we can create using 4 spaces at a time, we can now apply the given to the formula. So it will become 7pr equals 7 factorial over 7 minus 4 factorial. So in result, it will become 7 factorial over 3 factorial, and that is equal to 7 times 6 times 5 times 4 times 3 times 2 and
So in order for us to find out how many words we can create using 4 spaces at a time, we can now apply the given to the formula. So it will become 7pr equals 7 factorial over 7 minus 4 factorial. So in result, it will become 7 factorial over 3 factorial. And that would also equal to 7 times 6 times 5 times 4 times 3 times 2 times 1 factorial over 1 factorial. We all know that if we cancel out 1, and if we do that, all that's left is 7 times 6 times 5 times 4 times 3 and times 2. And now, if you multiply all these numbers, you'll get 5,040. Now, that just simply means that we can create 5,040 words using 4 spaces at a time out of the 7 letters of the word crystal.
And now for our theorem 2 is where the number of permutations of n different objects taken are at a time and repetition is allowed. And the formula to be used is n raised to r.
Okay, so for example, how many 3-letter words with or without meaning can be formed by the word dogs when repetition is allowed?
In here, n is equal to the number of letters we can choose from, which is 4. And r is equal to the number of letters in the required word, which is 3.
And so n raised to r will be 4 raised to 3, which is also equal to 64. And so there are 64 words that can be possibly formed.
Are you still with us?
Okay, so for our last theorem, we both hope that we still have some energy left. So introducing
Theorem 3! the number of permutations of n objects where P1 objects are of one kind, and P2 objects are of second kind, and Pk objects are of k type.
Okay, so for example, we have the word Philippines, and we have to find its number of permutations. So when looking for the values of P, we have to look for the letters that have been repeated.
In this case, both P and I are the letters that have been repeated in the word Philippines. And so P1 will equal to 3 because P has been repeated twice.
And our P2 will also equal to 3 because it has also been repeated twice, which is I. And then N, which is the total of number of letters, will be 11.
Thus, applying theorem 3, we have 11 factorial over 3 factorial times 3 factorial, which will result to 1,108,000.
What's up, guys? So we hope that you enjoyed the topic and you've learned something from us today.
And we also hope that you use this knowledge that you've gained to teach other people and to apply it in your daily life.
So it has been Celynne.
It has been Diana.
And bye!
Bye!